Welcome to University Place Presents. I'm Norman Gilliland. You may have heard of IceCube, the observatory that takes up a cubic kilometer of ice in Antarctica. Well, we're curious about not only what IceCube is for and what it does, but also what it's like to work and live in Antarctica for a long period of time. After all, it is the world's largest and coldest desert. With us, two people who have worked there considerably on both IceCube and other projects and spent a lot of time in Antarctica. They can give us some insights into the psychology and the day-to-day life of a person who spends much of their career in that remote place. They are Reina Maruyama and Mark Krasberg, and welcome to University Place Presents.
Thanks. Thanks, Norman.
Thanks for having us.
Well, we'll have a lot of pictures. That's one thing I think you have to say about Antarctica. It's a very photogenic place, even if you're just looking at, a seemingly endless horizon. There's something very striking about it. And you have also worked at the South Pole, which has to have even more special qualities than, say the fringes of Antarctica that are available even to tourists. So I think we have an overview of the South Pole Station. And how long have you spent there, and what is so special about the South Pole that you have to go there?
Right. So let's see. I'll start. So I've been there for 2 seasons, so you can only get to the South Pole during the austral summer, so between November and February. And so I've spent a total of some 5 weeks or so. So first time I went for 2 weeks, and next time I went for 3 weeks. It's a really great place to work there. Everybody, who goes there has a reason to be there, working hard and, making whatever experiments that they're working on happen.
How many people would be at the South Pole at any given time? I mean, what would be the most number of people working there?
Yeah, so during the summertime, there are some 250 people working there. And during the winter, when the station is closed, the transportation to South Pole is closed, and there are between 30 and 50 people staying there between February through October until planes can access them.
So once they're there, I mean, if you're there in February, you are there until October. You're not going anywhere.
That's right, yeah.
And it's dark the whole time. Except, I suppose, you must get some moonlight occasionally. How does that work?
Right.
Yeah, Antarctica is South Pole, the way the Earth spins. South Pole it's not 365 days, 365 nights. It's one day that lasts about 4 months, a 2-month sunset, then a 4-month night, and a 2-month sunrise.
And when you're actually at the South Pole, then, so you're seeing the sun just kind of circle around above the horizon in the summer.
Yeah.
And in the winter, you're not seeing much of anything, although I would guess stars. I mean, are the skies clear there?
Yes, they see beautiful night sky, and they actually get auroras frequently, beautiful auroras. That's one of the reasons that the people like to spend winters there.
And we call it the aurora borealis. Up here, down there is the aurora australis, the southern equivalent. Even more brilliant, though, than what you see in the northern hemisphere, you think?
No, I think it's not. I haven't heard that it's more brilliant. I think people have said some of the nicest ones they've seen have been in the north. But the advantage of being at the South Pole is the auroral oval will sometimes come over the South Pole Station daily, and so they can see beautiful auroras sometimes every day for 2 weeks on end.
Now, we've mentioned IceCube, and we don't want to gloss over that entirely, and I know that there are other projects affiliated with it too, but we should get into a little bit about what IceCube does before we get into what it's like to actually work there. And I've already mentioned this cubic kilometer of ice, which is kind of mind-boggling in itself. Is it? And you have mentioned, I think, that it's an observatory. This facility is actually an observatory, but with a cubic kilometer of ice in the ground, is it looking down or is it looking up?
Yeah, so the telescope, several years ago there was an article in Scientific American where they talked about the 7 wonders of modern astronomy. And they talked about the different telescopes, and they gave each one a nickname. And so the Hubble telescope was given the nickname the sharpest. And our telescope, our observatory, was given the nickname the weirdest. Because what we did was we put a telescope, an observatory, 5,000 sensors, a mile and a half down in the ice, in clear ice, in the dark. And the sensors look into the Earth because these cosmic particles that give off a little bit of light as they go through the Earth. And the only particle, there's only one particle that will go through the entire Earth, and that's a particle called a neutrino. And
subatomic particles.
Yes, yes. And so when we see light, when we see a particle going through the ice, where it's coming from, like the North Pole, or from the center of the Earth, or from Wisconsin or Europe, from that direction, because we're deep down in the ice at the South Pole. When we see a particle coming from below, we know that that's the particle we're interested in, which is a neutrino.
And how do you know when to expect them? How often do they come through?
So let's see. So we're getting some 3,000 events per second in the detector of IceCube, and then the trick is to look for neutrinos that are, so only 1 in a million is a neutrino, and so then the trick is to sift out all those background and events that we don't want and look for that 1 in a million event. So the way you do that is, as Mark mentioned, you look for ones that are coming from below. Most of the events are cosmic rays that are coming from above the detector, from the sky. So if it's coming from below, we know that it's a neutrino. Other signatures are, you're looking for energy of these particular particles. And so if they're outside of what we expect from what we know should exist within cosmic ray, then we know that these are neutrinos that, we haven't expected before. These are events from.
I hear about the Crab Nebula, and we have an image of the Crab Nebula. Mm-hmm. Crab Nebula, he said here, this explosion from about 1,000 years ago. And how does that bear on your research at IceCube?
Mm-hmm. So that's just astronomers take pictures of the universe in different ways. And so I think the picture on the screen is a visible light picture of a star that exploded 1,000 years ago. And that's, if you have a fancy visible light telescope, you can see that. Then what people have done over the decades, since Galileo invented the first telescope 400 years ago, is they've taken the pictures of the universe in different ways, including X-rays, infrared. I think there's a slide up showing that. Just like you could take a picture of your hand with a camera, and you could take a picture of your hand with infrared and see the heat, and you could take a picture of your hand with X-rays and see the bones, or with magnetic resonance imaging and see the tendons. Astronomers take pictures of the universe in different ways, and they learn more and more about the universe when they do that.
Various properties, whether it's the heat or the energy source or something like that.
And so what we're trying to do is take a picture of the universe using this subatomic particle called a neutrino, and no one knows what that picture looks like, and that's what we're trying to do.
And how does dark matter play into this, Raina? I mean, you're working on that in particular.
Mm-hmm. So what we did was to install a specific detector that is to look for dark matter in the ice that's co-located with IceCube, but a slightly different technology for looking for dark matter. So dark matter, we expect that they're essentially there's a halo of dark matter around the galaxy, and our detector, or the Earth, is essentially streaming through this dark matter. And so we're looking for this dark matter to collide with the material in the detector itself, and looking for a specific signature that we expect from such a particle.
And we're interested in dark matter. Why? Because it's such a large part of the universe?
Exactly. So of what we can see using a telescope, we know actually that only 5% of the universe consists of matter that we think as ordinary matter, like protons and neutrons, hydrogen, helium, and neutrinos. So this is matter that we can see, but gravitationally we actually see more matter out there. So some 23% of the universe is what we call dark matter, and the rest is actually dark energy. So 70-some% is dark energy. So we're not looking for those, but so we're looking for what could be exerting gravity, so much gravity activity on the universe, and we really don't know what this dark matter particle, what it is, how it interacts with or whether it interacts with normal matter at all.
But Antarctica is the best place to study it.
We think that that's one location to look for it. Yeah.
And I think here we have an image of what Ice Cube actually kind of looks like in the scheme of things. Mm-hmm. And what are we actually seeing here?
Mm-hmm. So what we're seeing here is a picture of the ice cube detector. So on the top, you see where the hexagonal array is. So that's top of the ice cube strings, we call it. And then we drill holes into the Antarctic ice. And the bigger dots that you see between 1450 meters and 2400 meters below the ice are optical sensors that we've instrumented in the Antarctic ice. And so when neutrinos or charged particles go through this ice, they emit some light. And by detecting where this light is detected using our sensors, we can reconstruct where these particles might have come from, and also their energy as well.
And this gives us, I think, here some idea of what it actually looks like going through this cubic kilometer of ice.
That's right. Yeah.
So this is a charged particle. This is what happens when a charged particle goes. This is our event display, and this is an event where a charged particle is going through the ice from below towards the surface, and we use the colors of the rainbow to signify time. So red, orange, yellow, green, blue, violet, and so then that red line on the image is the actual computer reconstructed path of the particle, and the size of the dot represents the amount of energy. So at the end of the day, we figure out the direction and the energy of the particles that go through the ice, and then we make a sky map of where they come from.
Should I ask at this point what any kind of perceived, I know you hate this question, but it's one that you're going to hit with sooner or later, practical application question?
So this is a question that we get often. I'm not so sure about the practical applications, but we're really trying to understand how stars work, how our universe is put together, evolution of our universe. So if you want to think about how we came to be and how we evolve, I think those are the questions we're trying to answer.
And it's also true that basic research is a fairly good fundamental thing for, say, a government to do. And when you do that, every so often, some group will discover something really amazing and neat and important that the country benefits from. And you never know where that lightning is going to strike. So this is a neat project, and we're trying to learn about the universe. Practical applications, that's debatable, but a lot of fundamental science, it's debatable.
Yes, well, and I suppose, if you're talking about the various, the very fabric of the universe, there is some relevancy to that, to knowing what it's made out of and how it works. This will give you some sense of the size of Antarctica. That is a lot of desert there, compared, of course, to the United States. It's bigger and a lot colder. And now, do you spend, when you're in Antarctica, do you spend most of your time, you pretty much go straight to the South Pole? But there are a number of other research stations on the continent, right?
Mm-hmm. Yeah, so we fly to McMurdo Station, which is the big U.S. base on the coast. And that's a slide from the air showing McMurdo Station. It's kind of like a mining town on lava rock.
That's kind of the New York City of Antarctica.
The biggest. And you can have it's the biggest one there, and it'll hold over 1,000 people. And in that picture, you'll see that there's actually an icebreaker in the left edge of the picture that's cut a channel. So during the summer when it's warm, it's typically 4 miles from the coast where McMurdo Station is. It's right on the edge of the water or the ice. It's 4 miles to open water, and so every year they have to cut a channel so that a cargo ship and a tanker can come in with supplies. And so we all fly there first, and then several countries will use McMurdo as a jumping off point, and they fly. We go through New Zealand, fly to McMurdo Station, and then we go. Then the different groups go to the different bases within Antarctica.
So
to
from
do research.
Wisconsin, it would be what, about like 72 hours of flying to get to the South Pole.
It's a lot.
A
It takes several days, but then you get like some training and orientation and gear and clothing before you. So it takes several days to get there, basically. Yeah.
What about the politics, for want of a better word, of Antarctica? I mean, we hear that, of course, it's a multi-national venture there, research venture. Are there any parts of it that are actually claimed by any given country? I mean, is there still a Russian part of it and an English part and a Norwegian part, and as well as an American part, or how does that work?
Well, so where we work is at the U.S. Scientific Station, but of course we have people from other countries staying there, and there are many stations across Antarctica that belong to a particular country so different countries set up their own scientific bases, but the continent itself it isn't supposed to belong to anybody, and so the idea is that it's a place for everyone, all the countries.
And it's off limits to mining and obviously nuclear testing and that kind of thing.
Right.
The only commercialization that I know of, I think, is probably tourism. There is a little bit of tourism, but yeah, any project anyone does, they have to get permission from some world body that approves it.
We'll talk a little bit about tourism later, I mean, because it's somewhat different from what you do there in terms of the places people get to see, the parts of Antarctica that they get to see. I gather that's a little bit more of a fringe experience for the tourist, although still certainly a place that's very different from home, wherever they come from. Now, a little bit about, I'll call it fashion in Antarctica, even in the summertime. Tell us about some of the layers required. If you just were to go out to, I wouldn't say walk the dog, but if you were just to go out for 10 or 15 minutes.
Well, so growing up in Wisconsin, or for those of you who are in Wisconsin, I think you know what it takes to go out in whether a -20 or -40. So layers is important. What you see on the screen is the American fashion, where we get red parkas issued to us before we get to Antarctica. So the layers are what you normally think of. So long underwear, long fleece under our shirt, and then perhaps another layer, and then a big parka that go on top of it. On warm days, it's actually quite possible to go with fleece layer and a windbreaker.
And a warm day means what?
-20.
-20 is a nice one. No wind.
Yeah.
The important thing
Good
is no
summer
wind.
day.
No wind, right? Yeah. And then the boots is something else. So yeah, since you're walking on cold ice, you're essentially, what you want is thick-soled boots to keep that cold away from your feet.
Possibility of outdoor sports?
Yes, actually, that's not a very good golf shot, but that's me hitting a drive at the actual South Pole marker. So yeah, no, actually, it turns out golf is a really fun sport to do there. We used to play to some of the holes that we had drilled in the ice.
I was going to say, but you don't. Well, first of all, the ball is orange, but
Right.
that helps. But you don't just lose the ball in snow. Or
Well, it's kind of in a lot of the area around South Pole Station, it's packed snow, and so as long as you don't hit the ball very high up in the air, it doesn't bury.
You must get a pretty good, as they say, a very fast green, though.
Oh yeah, no, we would play. We would actually the holes we would play would be about 1,000 yards, and it was. Yeah,
The altitude helps a little bit.
The altitude. So a lot of people, I think a lot of people don't realize that we're on top. The South Pole Station is on top of 2 miles of ice, so we're at high altitude, very dry. One of the things that I think in that picture before, which showed the gear that people were wearing, is the goggles and the sunglasses are very important. It's very bright there during the summer. You literally cannot walk more than a couple hundred yards without goggles and sunglasses before you have to shut your eyes.
You become kind of snowblind.
Yes, I can see how people go snowblind. Yeah.
And now we have is this, I think, just kind of a particularly typical landscape, or what's going on in this one?
This is a particularly nice landscape on the flight between McMurdo Station on the coast and South Pole Station, right in the middle. And these were some very nice clouds I saw from over the transantarctic mountains as you fly between because we're basically going up in the air. You know, we're going up a mountain range as we go to South Pole Station.
Yeah, we don't hear a lot about the mountain ranges, but are there actually active volcanoes in Antarctica?
Yeah. So near McMurdo, there's one where you can
Mount
sometimes
Erebus?
see.
Mount Erebus.
Yeah.
It's a very impressive. You get off the plane and you see a volcanic plume coming off the top of this 14,000-foot mountain right in front of you.
So if you want to warm up a little bit, you have to. I have heard, however, that there is, what do they call it, the 300 Club? Where, because you can actually have, if you're in a sauna in Antarctica.
Yes, we can talk about that in about 2 slides from now.
Okay. In the meantime, you must get some interesting light effects down there.
It's amazing.
Yeah, you want to go?
Well, just that's when I don't feel like I'm on Earth. So most people, even if they haven't realized it, they've seen sundogs. So if you look up during the summer, you see the sun, and maybe 30 degrees to the right or left, you see a bright spot in the sky, and those are sundogs. And they're caused by ice crystals in the air, in the sky, in the air. And the poles have lots of ice crystals. And not only do you get sundogs, but if you see it in this picture, you get sundogs, you get halos around the sun, circles around the sun, you get secondary circles, secondary halos, you get inverted rainbows, and you get something called a parhelic arc that goes around, horizontally around you. And that particular photo, you see, that's a good one, but you see these halos every couple of weeks. And you don't normally see them when you're not at the poles.
And this is with or without the sunglasses.
So you were asking about the 300 Club.
Yeah.
So in the wintertime, neither Raina or I have experienced super cold weather. The coldest I've experienced is like minus 70-ish Fahrenheit.
Yeah, I don't even come close.
Okay.
Yeah.
But during the winter, occasionally it'll get down below minus 100 Fahrenheit. And the people who are there, what they like to do is turn the sauna. There's a sauna in the station. They turn it to plus 200. And it's dark. It's winter. It's dark. It's night. It's plus 200, and then they get out of the sauna and they run around the South Pole mark.
This is
naked.
Yeah, I was going to say, with or without clothes.
Except for shoes.
Probably without. Yeah, shoes, good idea.
Yeah, and then they're a member of the 300 Club.
And how fast a run would this be? I mean, even if you've been soaking in, 200-degree sauna, if it's 100 below zero outside, I think you couldn't be out there too long in any occasion.
No, not too long.
That's certainly impressive. And we mentioned also some of the Aurora Australis, and this is another example of that, I guess.
Yeah. So this is an example of the aurora, and in the foreground you also see the ice cube counting house. So this is where all our data is brought up from the ice and then processed, and so that they can be transmitted over satellite up to Madison.
And this is summer.
No, this is
winter.
This is winter. So this is a fairly recent photograph taken by one of our winter rovers. There's 2 people working for the university there right now, and they're trapped until, as you said, until October. There's no way out.
They have to, as you did, I assume, go through a fairly rigorous physical exam to even go down there, because obviously you don't want somebody who's going to suddenly need some, heart surgery or something if it's March in Antarctica.
That's right. Yeah. So everyone who goes there goes through a fairly extensive physical check. So we do that, and then I think winter rovers, in addition, go through additional layer of physical and mental, psychological.
Well, let's talk about the psychological. I mean, what would be the psychological afflictions? I mean, the first thing I think of, which wouldn't be right, would be the submariner would be subject to claustrophobia after a while. But this is a little different from that. What are the psychological
They get like
you
a
have to watch for?
questionnaire with like 800 questions on it. And then I think they've told me one of the themes that comes up during the questionnaire is whether or not they like to play with fire.
It wouldn't even have occurred to me there was anything flammable down there, but I suppose there must be something.
It's 0% humidity. It's the driest place on Earth.
Right.
And so they're very worried about fire.
Yeah, so even one little errant spark. I gather that things, this wouldn't necessarily be the case of the South Pole, but I gather things just last forever down there. I mean, things that, you know, you hear about these Antarctic bases from 100 years ago where the canned goods are still on the shelves. I mean, because there's virtually no bacteria down there to
Right, so it's
contaminate
cold.
things. And
So it's cold and it's dry, and so things tend to last a long time. So the picture you see here actually is a picture of drill camp of Ice Cube. So we used all of these, you know, what you see, the boxes you see in this is individual containers, you know, shipping containers that is full of water heaters and some tanks and so on. So this Ice Cube construction is now done, and so this camp has now been packed up and you know, brought into a closer packed unit to awaiting to be shipped out from the South Pole when the need for them is deemed to be finished.
the idea is that everything that goes in comes out.
Exactly. Yeah.
So watch your step.
Yeah.
Is this one of the holes in Ice Cube?
That's right. That's right. So this is one of the holes that was drilled for Ice Cube, and it's 2,500 meters deep. So that's what, a mile and a half deep into the ice. About 50 meters down, so 30 feet down, there's actually water. So it's the hole is filled with water.
There's natural water, you're
No,
saying, down there, or you fill it with water?
We use a hot water drill. We
I
use
see.
fuel to melt the ice, and we use a hot water drill and inject it into the hole and have some big weights on it. And in 24 hours, we've sunk down a mile and a half, and we've made a column of water this big around. And then we pulled the equipment out, and then we've still got a column of water this big around for about a day. And then we drop our equipment, our sensors down, and
So-
that's a sensor going down.
So that hole would be how big across?
Basically our sensors are about the size of a basketball.
Oh, that
So,
big, okay.
Yeah.
And you have how many of these in this cubic kilometer?
Roughly 5,200.
Okay, so I can see this would take a little while to set up.
That's right. So each hole contains 60 of these, and then there are 86 holes. Yeah,
That's a lot of neutrinos to catch.
we hope so.
Is this an Ice Cube crew here that we're looking at?
So this is a picture taken after one of these strings, we call them. So after 60 optical sensors were instrumented and dropped into the ice, and after each of these 86 strings, we take a picture of the crew who helped assemble these sensors.
So I gather there have been people who've been going down there for a number of years and spending
Yeah.
a long period of time.
Well, so Mark has been there
Seven
quite a
times.
few years, right?
Seven
so
times.
I've been there
So a
twice.
total of about 6 months, maybe. Yeah,
Yeah. So he would be considered an old timer.
I guess. Yeah, but I wouldn't winter, right? I wouldn't spend a year there.
Well, I was going to get into that kind of thing. I mean, this looks very cozy and friendly here, but then if you extend living, you know, indoors like that for, how long, 8 months or something,
Yeah.
it might get a little thin.
No, I think the ideal length of time to go there is 2 weeks. Yeah, no, it's for me. It's high altitude, cold, dry. I personally don't do well physically in that environment.
Well, that's true. I mean, and we don't think of the high altitude so much because you're so, as it were, blinded by the cold when you think about Antarctica as a layperson, that you don't realize that we're talking 7,500 feet maybe on the average here, and then it takes a while for people to get used to that in Colorado. So if you add that, 70 degree cold, below zero cold, and then maybe a little wind chill on
yeah,
top of that.
as soon as the wind starts blowing, it's nasty.
So that's like a triple whammy there that you have to get used to.
Yeah, so it's a fairly harsh environment. The South Pole Station, the scientific station, certainly makes it, you know, a lot more comfortable to work there.
But is it true that people, after they've been there a while, they don't get colds because there are no bacteria to pass around? There are no, none of the bugs.
Maybe you know more about this.
I think that's probably true. There's a limited number of people, and so what the people who winter there, as soon as the new people arrive in October, November, they all immediately get sick.
Yeah, that's what I was wondering about. So they get, in effect, they're getting a fresh injection
Right.
of contagion
Right.
each time.
Right.
Because you're going to be in such closed quarters anyway.
So on top of the fact they're not happy when they've had this private home for a year almost, right? And all these people, 150 new people show up, and they're not happy about that. And on top of that, they all get sick.
Yes. Well, special challenges. This is a spectacular outdoor view.
Yes, I got the by far the best thing that happened to me in my trips was I managed to get on that icebreaker I mentioned for a day and a half, and this is actually the channel that it's cut, and this is a part of the channel where there's no more ice, and so it's basically 200 or 300 yards wide, and it was a nice summer's day, and I was on the ship going up and down this channel, and when they cut the channel, a lot of wildlife will follow the icebreaker down because they can swim under the ice, they can breathe, and then they can swim under the ice and catch fish and whatever. And so we saw a lot of whales, and these are killer whales. And I kind of like this one because there's a penguin up near the top.
Right.
Those particular whales don't attack penguins, but it was just it looks good.
So there is a point, though, somewhere beyond the coast, where you just don't see any life of any kind. Is there? I mean, you get beyond obviously the sea life, but I assume you also get beyond the bird life fairly quickly too.
So at South Pole Station, there's no life except humans, except twice in the 6 months that I've been there. Twice I've seen a skua fly overhead, which is a large seagull.
Really, that far?
But they say that when a skua has reached the South Pole Station, it's probably not going to make it back to the coast.
You wonder how it could.
It's lost or something.
The South Pole itself is roughly how far in from the nearest coast?
600 miles?
Sounds right, yeah.
Yeah, so it's amazing to think that a skua or anything else would fly that far in with no great prospect of anything to support it.
Right.
How far in for the penguins? I think of them as being pretty much coastal too.
Right. They only go in, I think in the movies I've seen, they only go in like 50 or 70 miles or something. Yeah.
But once you were in their neck of the woods, they seem to be all over the place.
Yes.
Right, yeah.
And so this picture here is of some Adelie penguins. So when you watch these movies on TV like Happy Feet and and Parks and Penguins, the penguins all have different personalities. And in the movies, they actually do a fairly good job of depicting the different personalities of the different penguins. And so these are Adelies, and I literally fell asleep on the rocks watching them because they were little kids running around for hours, picking up stones, and they were just incredibly fun. Yeah.
Right.
So let's talk about the tourist part of Antarctica. Where would a tourist actually have access?
Well, so from what I've seen, there are boats that come in to near McMurdo, and what I saw was that they get flown over, onto near the station with helicopters. So that's what I've seen. So they get a tour of the station.
So they come down by boat, but there's helicopter transportation on the boat.
I believe that's what's seen. So near McMurdo Station, there's the Scots Hut. So that was one of the bases, I guess, for the Scott party.
Oh, sure. For Robert Falcon Scott.
That's right. Yeah.
Who actually perished during an expedition to the South Pole.
Right.
Yep. And then to the South Pole, you can take a commercial flight to the South Pole itself.
Oh, you can?
You can pay a company about $40,000.
Oh. Okay, the line forum's here.
They'll fly you there.
Yeah. And so they come and they take pictures at the South Pole, and they fly back out again. Yeah.
How do you actually dress for the South Pole? I mean, you've given us some idea of kind of Antarctic apparel in general, but I talked to somebody one time who said the only place she had ever been where she could, and this was, again, an Antarctic researcher, the only place she had been where she could not get warm was the South Pole, regardless of what she was wearing.
Yeah, that might be true. But, so at the South Pole, it's very, very dry, and so you know, as long as you have warm clothing, you know, that's and you know, you can always go into the station, so that's actually fairly warm. You can be dressed like this and keep
Really?
warm.
In the station, you mean?
In the
Yeah.
station. I would imagine that if you're working on the coasts near penguins and you know, doing geological work, you might be out in a camp somewhere, and that's where I imagine you can get cold, fairly cold, and you know, you're out in a camp as opposed to at a station, and so you have, you know, much less access to you know, buildings and heat and shower and that sort of thing.
Well, what's the energy source for heat at these stations? I assume the heater is running constantly.
So there's an ice runway that the planes that fly to the South Pole are they're called C-130 Hercules planes.
These transports.
They're military. They're operated by the New York Air National Guard, and they land on skis.
Right.
Okay, on an ice runway at South Pole Station. The South Pole Station needs approximately 300,000 gallons of fuel to run for 1 year. And every time one of those planes lands, it has external fuel tanks in the wings, and they siphon off about 3,000 gallons of fuel each time it lands. And so during the course of the summer, this 3.5 months when planes can fly there, when it's warmer than minus 60, which means it's warm enough so that the hydraulics on the planes don't freeze.
Right.
Then when every time one of those planes lands, they siphon off about 3,000 gallons of fuel, and they need approximately 100 flights just to get the fuel so they can operate for 1 year.
That's essentially they're stocking up for the winter.
Yes, yes.
So that's the main source of energy at the South Pole.
It's just standard
Jet fuel.
Jet fuel. Yeah. I think we have some these emperors.
These are emperors. So these emperors tend to not to be as exciting as Adelies because they'll often just stand and molt for about 4 months. but they're beautiful. They're prettier. And so these are Adelies near McMurdo. I mean, sorry, these are emperors near McMurdo.
They're about 4 feet tall.
They're bigger, yeah. They're four
Are
feet.
these the biggest
Impressive.
of the penguins?
I believe so, yeah. They're very impressive.
And can you pretty much just walk right up to them? I mean, they're more or less
We're
tame in
not
that sense.
allowed to approach any wildlife.
Are you not?
They can approach us, but we're not allowed to approach them.
They approach you, you have to like run away or
No,
something?
no, you don't have to.
So have you observed, other than the playful Adelies, have you observed any kind of interesting wildlife behavior down there?
I think less so for me. You
See,
spend more time
seal.
seeing
The key wildlife to see is if you're lucky, you see penguins, seals, and then if you're lucky, you see whales. As far as at McMurdo Station. And this is actually a picture of an emperor jumping out of a hole actually it's a facility where they study emperors. And so they cut a hole in the ice so they can go diving anytime they want and catch their own food. But because the ice is several feet thick, there's only one way back, and that's in a kind of a fenced-in area.
Wait a minute, how does the hole get there?
Well, the research have made the hole.
research. So the penguins will be attracted to it, and it'll give them a chance.
Well, no, they actually are studied. They study like 20 emperors, and they put them in. It's kind of like a zoo, but they're wild penguins, and they can go diving and catch their own food, but they have to come back the way they entered the water, and so you wait with a camera and. Yeah.
What's the status of the ozone that we hear so much about? The ozone hole that we hear so much about in Antarctica.
I don't know. Do you know anything about that?
So they have a very neat facility where they study like global warming and issues like that. It's called the Clean Air Facility at the South Pole Station. It's one of the best places in the world to study like global warming issues because there's no human activity. There's very little almost no human activity at South Pole Station, and there's no like plants and animals that give off like carbon dioxide and stuff. So what they do in the with regard to the ozone hole, I know I got a tour of it. They give really good tours, and they did talk about it. Basically, I'm not an expert on this, but what I know I can try and tell you very briefly, and it's the ozone hole. Every year in the fall, like September-ish, when the sun is now starting to poke its head up and can actually hit Antarctica, when the sun is coming up, it actually interacts. There's ice crystals in the air, and there's some kind of catalyst going on between the ice crystals and the sun, and the high altitude air, and you get ozone destruction. And at that time of year, there's this circular wind pattern around Antarctica, and basically what that means is this column of air around Antarctica, and it's kind of trapped there. And so what you end up doing is you kill, all the ozone is destroyed, and it's kind of trapped in this weird weather pattern. And then later on, that weather pattern disappears, and then everything mixes again. So they study this whole ozone hole it's a natural phenomenon caused by this weird effect and this weird weather pattern, and they study it. And then the weather pattern dissipates or whatever, and the mixing, everything mixes, and then the ozone hole disappears. And so they study that every year, and they study whether it gets bigger or smaller and all kinds of things.
Each of you, was there a point at which you felt at home in Antarctica? You felt, okay, now I have kind of mastered this situation, this work situation?
Well, I'm not sure I've come to that point, but you know, for me, you know, going there was just, you know, first time I think for anybody is just a fantastic experience. You know, it's so exciting. You're getting there, you're flying across this beautiful landscape. And you know, you meet all sorts of people doing all sorts of different science. So people studying, you know, penguins, and you know, whether the landscape there is similar to Mars. You know, geology people, and then you know, all the people who are flying balloons. So you know, detect balloons for cosmic rays, or there are other neutrino detectors. So these are balloons that can go up, you know, way up into the sky, 30,000 feet or something, and then they go around the Antarctic. So you meet, you know, people from NASA doing this sort of thing, and then you meet ice cube people. So you meet all sorts of people doing, you know, just crazy things. And so for me, you know, meeting all these people was really, you know, fun talking to them all. And then you get to the South Pole, and you know, for IceCube, we were a fairly big presence there, and so you know, this fantastic team gathers at the South Pole to make this, you know, this project happen. And you know, we're all there. We have very limited time to get our work done, and you know, we're on schedule, you know, and trying to get this detector built. And so it was a really exciting experience for me. And you know, I think all the team members are very you know, capable technicians, scientists, and engineers, and yeah, just good times all around.
Parties?
Yeah.
Mark, what about you? At what point did you feel?
I never felt at home there, but as far as you know, as Raina said, going there the first time, it was just incredible, and I think you know, maybe the seventh time wasn't that as great as the first time, but it's a neat place, and I felt very lucky that I got to do it. Yeah.
Either of you have a sense of if you could go there just one more time, what you would want to do in particular that you haven't done yet, or that you would like to do again, for that matter?
Well, for me, I'm trying to get this new project funded, so I'd like to get this built, and you know, I'd like to put it into the ice. And so, if we can go there again to do another project, that would be. This is for
dark matter.
Yeah, dark matter. So a project called DM Ice.
Sure.
For me, so I spent a day and a half on this icebreaker, and I would do a cruise, an Antarctic cruise, because there's a lot of good stuff to see on that.
So parts that you haven't seen that you'd like to see?
Yes, there's the other side of Antarctica, a place called, I think, Rothera, is supposed to be incredibly beautiful, and that would be and I know some of the cruise ships coming down from Chile, I think they go over there, and that would be a neat thing to do.
Okay, so you're still up for another trip or two each, are you?
Oh yeah.
Well, thanks for joining me today. My guests have been Mark Krasberg and Raina Maruyama.
Thank you.
Associated with IceCube, but also doing other things there too. And good luck with next trips to Antarctica and the pole, the South Pole.
Thanks.
Thank you very much.
I'm Norman Gilliland. Glad you could be with me, and I hope you can join me the next time around for University Place Presents.